When my daughter was little, whenever she got upset about something, she'd say, "You're ruining my life about this."
This episode is sponsored by Hired.com. Every week on Hired, they run an auction where over 1,000 tech companies in San Francisco, New York, and LA bid on Ruby developers, providing them with salary and equity up front. The average Ruby developer gets an average of 5 to 15 introductory offers and an average salary offer of $130,000 a year. Users can either accept an offer and go right into interviewing with the company or deny them without any continuing obligations. It's totally free for users, and when you're hired, they give you a $2,000 signing bonus as a thank you for using them. But if you use the Ruby Rogues link, you'll get a $4,000 bonus instead. Finally, if you're not looking for a job but know someone who is, you can refer them to Hired and get a $1,337 bonus if they accept the job. Go sign up at hired.com/RubyRogues. Snap is a hosted CI and continuous delivery that is simple and intuitive. Snap's deployment pipelines deliver fast feedback and can push healthy builds to multiple environments automatically or on demand. Snap integrates deeply with GitHub and has great support for different languages, data stores, and testing frameworks. Snap deploys your application to cloud services like Heroku, DigitalOcean, AWS, and many more. Try Snap for free. Sign up at snapci.com/RubyRogues. This episode is sponsored by DigitalOcean. DigitalOcean is the provider I use to host all of my creations. All the shows are hosted there, along with any other projects I come up with. Their user interface is simple and easy to use, their support is excellent, and their VPSs are backed on solid-state drives and are fast and responsive. Check them out at DigitalOcean.com. If you use the code RubyRogues, you'll get a $10 credit. This episode is brought to you by Braintree. If you're a developer or manager of a mobile app and searching for the right payments API, check out Braintree. Braintree's new V0 SDK makes it easy to support multiple mobile payment types with one simple integration. To learn more and to try out their sandbox, go to BraintreePayments.com/RubyRogues. Hey everybody, and welcome to episode 237 of the Ruby Rogues podcast. This week on our panel we have Avdi Grimm.
Hello from Tennessee.
Coraline Ada Emke.
Hi from Chicago.
I'm Charles Max Wood from devchat.tv. Quick reminder to go check out jsremoteconf.com. I'm actually doing 12 conferences next year, and you can get tickets to all of them at allremoteconfs.com. We also have a special guest this week, and that's Brad Urani. Do you want to introduce yourself?
Yeah, hi. It's an honor to be on the show. Long-time listener, first-time caller. My name is Brad Urani. I'm a web architect at Procore in Santa Barbara, California, and I'm very pleased to be joining you all today.
What do you do at Procore?
I'm a Rails architect. So Procore is interesting. We make construction management software. We're out in Santa Barbara. We're a company that's growing real fast, and it's a company that's, for the most part, a giant monolithic Rails app. In fact, we were a Rails app since version, I believe, 0.9, so the very, very early days. I didn't work here back then. I'm fairly recent here. But I work on various third-party integrations. I help us design basically our overarching architecture and class design, testing strategies, education, onboarding, recruiting, training, and various other things.
Architect's not a job title you hear very much anymore.
Yeah, I say that architect with a lowercase a. Truth be told, working at Procore is kind of interesting because our team is split into squads, and the amount of actual quote-unquote architecture we do is actually rather minimal. The Procore team has found over the years that you can get an awful lot done basically with basic MVC Rails, and it generally pays to err on the side of less architecture, not more. So it's been interesting because I come from a background of pretty heavy object-oriented design, and the dynamic works out surprisingly well.
So you recently, I was at RubyConf, and you gave a talk there on immutable data structures. What was that all about?
It's about persistent immutable data structures. And that's an idea that mainly comes from functional programming. So first of all, we have to basically differentiate between just persistent and immutable. Immutable is simply something where once you create it, for instance, take an array. If you create an immutable array, you cannot change it afterwards. Ruby has that with, for instance, array.freeze, which, once you've created that array, you can't, for instance, add an element or delete an element, or it will raise an error. That allows you to avoid certain classes of bugs, but it's not that interesting and not that useful. Persistent is a little bit different. So in Ruby, you can get a persistent data structure by using a gem called hamster. It's a really, really great gem. It's got a number of really neat data structures involved, persistent lists, persistent hashes, persistent sets, persistent vectors. And what persistence means is if you have a reference to array, so for instance, if you say A equals, an array of 1, 2, 3, and then you go and say unshift a 0 onto it. So you push a 0 onto the front. So you say B equals A dot unshift 0. Now B has a reference to a list of 0, 1, 2, 3, but A is still just 1, 2, 3. In other words, the original reference you have is pointing to an array that was unchanged. And if you think about that for a second, you scratch your head a little and say, well, how do you implement that? And the first thing that comes to your mind is, okay, I had this array 1, 2, 3. I added 0 but left the original intact. I must have cloned it, right? I must just have made a whole copy in memory. But that's actually not the case. Persistent data structure, a persistent list, is actually a linked list. So what you end up with is a reference A that's pointing to the second node in the list, which is 1, and B pointing to the first node in the list, which is 0. You've tacked a node onto the front. And in that way, by having a single linked list with 0, 1, 2, 3, and having A point to the 1 node and B point to the 0 node, you've managed to both alter a list and not alter it at the same time in a way that's memory efficient, that doesn't involve any cloning. It's a little tough to describe, but it's actually a very elegant solution. The main point being you allow changing of a list without cloning, and keeping all references to a list don't see any changes. They're effectively immutable.
What's the advantage of an immutable persistent data structure over just, messing with hashes, messing with arrays?
Admittedly, the applications for them are somewhat niche, but the primary benefit you get out of an immutable persistent data structure is that it allows you to keep perfect history. So any program you have that uses these data structures, as you change things, as the state of your programming changes, if the state is created out of persistent data structures, you can keep references to all the previous states. So this gives you, probably the neatest feature is a time travel ability. So that it's really easy to, for instance, program a state manager that keeps references to all the points in time, which allows you to travel back and forth, which is very, very clever. Of course, for that to work, you need to adhere to a certain architecture. Basically, all your state needs to be in one place. So if you take all the state of your programming and hold it in one object in one place, and you don't have other mutable state in various objects as instance variables in various objects, you get that time travel capability, which allows you to do some neat things, time travel debugging, among other things.
Are there tools for that kind of debugging?
There aren't in Ruby. This is an idea that it hasn't really come to Ruby because Ruby being, a purely OOP language, OOP to the extreme, in fact, so much so that everything is an object of course. It's somewhat of a niche application in Ruby. It is very, very prevalent in the functional programming world. Any functional language, because it's generally designed to avoid as much as possible, random state changes. It's designed to isolate changes into state to as few places as possible, is much more easily time traveled. The bulk of the functions are pure functions, which don't hide state changes in various instance variables. The neatest implementation I've seen of time travel using persistent data structures is Elm. Elm enforces an architecture of single state such that any program you build in Elm is time travelable by default.
Now, we did a whole episode on Elm. I'm kind of curious. We got the kind of the viewpoint, I guess, of Evan and I think it was Rob. We kind of got their viewpoint on things, but why do Rubyists care about things like Elm?
Well, first of all, we live in a world of the World Wide Web. So, just about everyone who does Ruby these days is also doing JavaScript.
Yes.
So, like it or not, at some point in your career, you're going to end up doing front-end development. And Elm brings to front-end development a new paradigm, just a new level that's unprecedented. That's just, in my opinion, knocks the socks off of any JavaScript solution. So if you want to do front-end development, look at Elm. But it can also, I think, be very instructive in perhaps where the future of Ruby should go. If people want to get involved in something that's completely different from Ruby, to further their careers, to further their own understanding, to further their own knowledge. These are kind of polar opposite paradigms. Although there are some interesting cross-sections, these are kind of opposite paradigms, and it's just a great way to become a well-rounded developer and to understand maybe something that you're not familiar with if you've done Ruby for most of your career.
Is it incompatible between the use of persistent immutable data structures and programming in an object-oriented way, or do you think that there's some meeting ground there?
Well, I think the persistent data structure use cases they're admittedly niche, but there are some interesting ones. particularly in algorithms. Algorithms where you have to keep a history of the steps you've taken are kind of useful. But even if persistent data structures are a bit niche, I think there's a lot to learn from functional programming in general. Definitely a lot that relates to basically everything from class design to database querying to application architecture in, for instance, a Rails app. I think there's a lot you can learn just from functional programming and the techniques involved there.
What are some of those lessons?
For instance, I spend most of my days working in Ruby on Rails. And Ruby on Rails is somewhat interesting because if you look at a web app, it can be described pretty simply as a data transformation, as a sort of data in, data out flow. Consider a web request comes in and you have parameters. You got your request parameters. You take that data, you send it down like a pipeline of data transformations to the database. Either you're saving or you're querying. You take that data back out of the database, you send it through functions, back up to the front end again. In a nutshell, that's for the most part all a web is. I'm simplifying a little, but that's for the most part what a web is. A Rails app is a set of functional transformations between a request coming in and either a read or write from a database. Functional programming also describes programs as data transformation pipelines. Now, the difference there between sort of what the Rails paradigm is or what the OOP paradigm is and a functional paradigm is that along that way, an OOP program would hold intermediate state and instance variables. In other words, you might take an object, you might set something, later you might retrieve that, you might change that instance variable, and do any other number of sort of things related to state changes within that request before you return the response to the user. What functional programming teaches us is that you can see a lot of benefits by minimizing the amount of those state changes you do in understandability and readability and especially testability.
So let's talk about the testability aspects a little bit. Can you elaborate on that?
If you look at active record, for instance, when you make a query, you're storing data in an object, and you may have methods that on that object that mutate the instance variables, that change the instance variables in there. It's really hard to write a test for that. In fact, it's really hard to write a test against models in general because, in order to properly test something that changes an instance variable in a model, you need to sort of reach in there using any number of Ruby tricks to ensure that the state has changed. And as you're programming, and you commit this code and your colleagues come along and look at it, keeping track of in this web request pipeline, sort of where you're expecting an object to be as it was original, where it has changed can be real hard. And it makes it real hard to unit test. If you design your web application architecture, kind of your design such that your functions are pure so that you pass a parameter to a function and you get a result back and it doesn't change any state, that is so easily testable. I call it embarrassingly testable because if anyone caught you not testing a class like that, you'd be embarrassed because it's so easy to test. Then you can write a single unit test against a single method in distinction to, for instance, an integration test, controller test. It helps your testability greatly just to write pure functions because every pure function is very, very easy to test. So, what I call sort of a functional object-oriented design, in truth, it's not so simple. My application architectures are typically this amalgam of OOP and functional programming and good old procedural programming. By doing as much of it in pure functions as possible, all the parts that are pure functions are so much more easily unit testable. And I mean unit testable in the strictest sense, meaning one test, one function.
Can we take like a typical Rails CRUD application? Where does functional play a role in that?
The first thing I like to do, looking at a Rails app, if you start by reading like beginner's tutorials, there's a sort of like idealistic world where you have one view, one controller, and one model. So you've got a user view, a user control, a user model, which corresponds to a user table in the database. If you've done enough web development, you come to learn pretty quickly that the world is rarely so simple, that oftentimes a single view is going to be displaying data that's taken from multiple tables joined together, and then it's going to undergo a number of transformations on the way based on your business rules. And then also the way it's displayed in the view might be in a drastically different structure, often a hierarchical structure, than it is stored in the database, which is a relational structure. So you realize that sort of the idyllic MVC, which is 1-to-1-to-1, doesn't quite hold. So now you're forced to sort of come up with a way of, okay, how am I going to manage these sort of changes in my data? First of all, at the query level, joining and combining. Then at the business logic level, deriving data, deriving stuff based on my business rules. Then at the view level, arranging things so that they are easily presented to the view. And functional programming can help us. The first step I do is try to separate the logic from the queries. If you just use basically models can make that hard because, if you naively go about jumping into your model and writing methods that have both business logic and queries combined, then when you go to test, you're forced to stub those queries or you're forced to plant data, both of which sort of violate the idea of a unit test. But if you can separate logic and make your models rather dumb, and do very little, but treat them more as like just a struct, like, something that just holds data, and you pass those into a class that actually does the transformations. You can make those classes that do the transformations pure class. They take data in the form of models or hashes or structs or what have you, and then spit out what needs to go to the view. Now those are pure, and now it's really, really easy to unit test those. You'll end up with cleaner tests, better tests, getting at the heart of what you're testing by separating the logic from the queries. And now you come up with something that's informed by functional programming. Because of that, more testable and less likely to have bugs in it.
I've always taken issue to active record being called active record because it seems like an active record model violates SRP in that it is responsible for persistence and business logic. But I actually went back to the patterns book and saw that that's what active record is supposed to be. So that kind of diffused that argument. But I think it's a great idea to separate persistence from business logic. Now, do you do that through, in the case you just mentioned, service objects or view objects, or how is that implemented?
I use service objects, but I also like to distinguish between objects that read and objects that write. So command query separation. So in my Rails apps, I have controllers called either services if they're GET requests, if they're fetching data, and I have them called commands if they're writing data. And actually, there's a precedent for this. Actually, Martin Fowler, he calls it the transaction script pattern, where you have a single class that represents basically a single transactions of things writing to the database. So the basic answer is Correlline is yes. Using service objects, but with that additional command query separation, you get something really neat when you do that. In a lot of web apps, you want to offer the users a feature that shows sort of a history of actions they've taken. You opened an account on this date, you deposited money on this date, you withdrew money on this date. If you do your program using a service layer with separate commands and services, depending on whether you're reading or writing, you can have like a command base class where you're basically keeping an event log, which allows you to have that sort of transaction history. That's a user feature. So if you need that capability in your application, that comes in very, very useful. And then, of course, every web app these days is reporting analytics, heavily reporting analytics, so you can do data-driven analysis of your users, what they're using, what features they want to do. Having a command-based class for all your commands allows you to basically for free send off analytics events to your Mix panels, your Google Analytics, or maybe your own internal solution so that you can basically much more easily build a BI solution. So that's really neat, really useful. And the other thing I find is that one of the issues I have with Active Record is that it tries to handle database transactions for you. For instance, when you hit .save, anything that appears in a callback, don't get me started on callbacks, automatically are in the same transaction. But that can lead to trouble because, say, for instance, you have one callback that, does a database update, a SQL update. Then you've got, another one that goes and fires off a third or API request to a third-party API. Well, you're doing that API request to a third party inside an open database transactions, which means potentially you're blocking a table. You're locking a table, in Postgres. In other words, relying on a framework like Rails to handle database transactions for you can often lead to trouble in ways that, if you're large scale, won't scale, because it's trying to do what you need to do explicitly, which is handle database transactions in the most efficient way possible, making sure that all your creates and your updates are all together in one transaction with as little else happening, which becomes important if you're at scale. So that's another benefit of that kind of command pattern.
What's wrong with callbacks? She asks sarcastically.
Right?
Callbacks are of the devil.
Yes. We all love that when we go into Rails C to make a little data update, and then all of a sudden we trigger off some massive cascading chain that we forgot about that affects 50 different things. That there's plenty of literature on that topic. I don't think I need to, endorse that one heavily.
The fun never starts.
Yeah.
Oh, man. And it's so funny, too, because I know it's there. So every so often I go in and I create a callback because it's like, oh, I'll just create this real quick because I just need some quickie little thing done. And almost always comes back around to bite me.
I'll allow myself a before save, but that's about it. If I want to set a default value or something along those lines, because getting to initialize in a Rails object is not easy. So
Yeah, I think with OOP, if you look at the early literature on object-oriented programming, all the way back to the Gang of Four, a lot of that was written in a world of desktop applications. And desktop applications are inherently stateful. Picture, for instance, Microsoft Word. You may have multiple windows open, various things, talking paper clips or whatnot on your screen. It kind of makes sense for all of those to have their own state. Imagine them as kind of separate components in a single application. And those things, they stay on screen. That makes sense with object-oriented programming because you have objects with instance variables. It seems to me kind of that we took those paradigms and we transported them to web, where perhaps in server-side web, where perhaps things are a little different because the web is inherently stateless. The only state in a web app is the cookie and what's stored in the database. So to have objects which are created and destroyed with every request, it kind of weakens the case for that just a little bit. What you start to realize when you get involved with functional programming is that functions represent actions and classes can also represent actions. So typically we think of classes as things, a user, a shopping cart, but you can also use them for things like a sign-in, right? An add to cart, something like that. And in the context of web, it can make a little more sense.
That's something I learned from working with Corey Haynes years back. I had always been taught that nouns are objects and verbs are methods, but to have classes that represent processes, that represent verbs, can be very freeing and can really keep your controllers nice and thin too.
I saw somewhere there's like a researcher invented a language that was verb focused. English is a noun focused language. Typically, we start with the subject of the sentence and only then produce the verbs. But it's interesting to think about what would our language be like if we put the verbs first and represented the world around us in terms of the interactions of things, the actions, rather than trying to picture the world as a frozen state of matter.
I can tell you how it would be if we had verbs first. Go to the store, I did. Yeah.
That's it. So functional programming is like Yoda.
That's right.
Everyone loves Yoda.
Hey, Brad, I have a question.
Yeah.
You started a new job like a year ago, was it, that you moved out to Santa Barbara?
Been about 6 months. I left St. Louis and moved to Santa Barbara, California.
Well, it seems a lot longer without you.
Oh, thank you.
We miss you in St. Louis. When you got there, how receptive were your coworkers to this slightly different style of Ruby and JavaScript?
Well, I'm really lucky in that as I came out here, I found that a lot of my coworkers are writing Ruby on Rails by day, and they're very interested in functional programming. Spending a lot of times on nights and weekends being interested in these things, in Elixir, in Haskell, in Elm. So it's been neat because, I've come from a background of very small, early stage startups, starting with either greenfield apps or very small apps that could be more or less completely refactored or rebuilt. And here I've come into a place with a giant Rails app that's 8 or 9 years old, from all the way back from Rails, like .29 or something like that. So what's interesting here is, it's impossible to come in here now and refactor an entire app to use, the things I've talked about, command principles and service principles. So there's a new challenge now in deciding, on a case-by-case basis, on a request-by-request basis, whether it makes sense to implement these patterns in very small places. So it's been nice because everyone's been very receptive, and we've been able to very slowly, in a few places where it makes sense, implement it where it helps us without, broad sweeping dictums about, all right, we're going to switch to this pattern everywhere. And that's kind of a new challenge that I've really enjoyed.
Do you find any negatives from the inconsistency in the code base that the change in coding standards and styles leads to?
No, we don't have standards. It's in a good way, and I say that very positively. That we're built into teams. we're split off into teams, and everyone is allowed to do things the way they want to do it without an architect, saying these are our standards, these are our styles. And what that means is that all the ideas we have live on their own merit, so that if certain teams don't see the value in like a service or command style pattern and they want to do their Rails, basically MVC, then they do that and it works and they knock out features and everyone's happy. And then other people apply it where it seems like it's really going to help. So for instance, if I want to model something as an action, like for instance, take some kind of request that makes a write that does multiple updates and creates, you can model this as a single transaction in some kind of command pattern, and then you get the benefit of, well, not only can I call it from controller, I can call it from a rig task. People see that, and rather than having someone top-down architecting things, every idea lives by its own merit, which is a really neat process, really neat to see.
When you say your own merit, is that do you measure that by how much people like it, people on that particular team?
We try not to over-architect, and we try to do things when they're useful. So it's basically...
No, that makes sense. I just kind of wanted to call out the part where merit is always subjective.
Oh, yes. So in programming, most of decisions about design aren't really objectively measurable. People have tried to do empirical studies of how changes in class design, even in testing practices, can be measured, and how you can prove that a certain philosophy, a certain methodology is better than the others. Most of those I find to be most of the studies, most of those sort of attempts to empiricize this, I find to be rather dubious, although there's some interesting things about testing practices and the number of bugs they produce. So it is definitely subjective. But, I don't think subjective quality, just because something is subjective in quality, means that you should not attempt to measure it.
Yes, I agree.
So I had a question. You talked about Brad working on a monolithic Rails application, and I know a lot of companies are dealing with their monolith problems by refactoring to service-oriented architectures. Do you think that SOA lends itself well to functional programming?
I don't know. Like SOA versus monolith has too much of a profound impact on that. It seems like within a monolith or within a service, you can just as easily use a more object-oriented approach or a more functional approach. I know you have some experience with that. I saw a great talk you did at the Kansas City Developers Conference 2 years ago about smashing the monolith. I don't know. What do you think?
I think refactoring to a service architecture lets you undo a lot of early decisions that you might have made in the architecture of your original system. And I don't know. I've been thinking about this a lot, and I'm wondering if service-oriented architectures are harkening back to the RPC days, remote procedure call days, as opposed to implementing REST, more of a REST approach to architecture. So it seems like if we're doing RPC again, that a functional style would lend itself really well to that.
In Scala, there's definitely, at least in Twitter, and people who use the Twitter finagle library for service interactions, it is much more of an RPC attempt than REST.
The alternative is to, invoke an object with a lot of parameters and let your controller do its magic. But I think being more direct and more upfront about what it is that you're doing with an endpoint is an advantage.
I completely agree, and I'm glad you brought it up. I think, for instance, if service or not, you could look at a Rails app and using kind of the architecture I described, using services to fetch things and command to model verbs, not nouns, definitely lends itself much more to RPC than REST. It goes back to actions versus things. Mm-hmm. If your web app is fundamentally modeled around things, which is kind of what you get if you follow kind of the Rails way, REST does make more sense, but RPC is definitely more in line, so I completely agree.
Even when you're not trying to make it RPC, there's things like GraphQL that we're moving past REST. REST is not the most efficient data access method. And I think you're right. REST is very thing-focused, and we're kind of getting past that as a community. But Brad, I liked your point about you have a monolith. You're not breaking it up into services necessarily, but you're still able to change and evolve your coding style team by team at will. So you don't have to move away from the monolith to gradually improve your code.
Yeah, that's right. It's something that's taken me a while to adapt to. As I said before, I come from a world from through Java and C# and other things of sort of real kind of top-heavy Gang of Four style OOP world. And the thought, if that's what you're used to, the thought of a lot of different teams working on the same app in slightly different styles can strike you as, ooh, are you sure that works? And I found it really does. I think it's real fascinating, and I think it's been a smashing success.
Cool. I think part of what our programming philosophy is changing is to realize that change is a constant in our programs, to not expect to be able to architect the perfect, pristine OO application and have it stay. And once we embrace change as the normal state of things, then that sort of constant improvement feels more natural. But if you can break out services, please do.
I thought there was an interesting article. I can't remember who wrote it. I want to say Fowler wrote it, but I'm not positive, about monoliths as a necessary stage in the development of a mature application, like as opposed to going straight to services where you have no idea what the service boundaries are. You have no idea what your domain objects are, and you're going to make a lot of mistakes in the architecture and your data model. That monoliths are really great for that. And once a monolith is built, you can easily separate out concerns and see where those seams are and then refactor to services.
I actually originally started out that way with devchat.tv. I started out with it as services. And I felt all of that pain, pulled everything inside, figured out where things are, and now I'm starting to spin things back out.
Wow.
So I can attest to that.
Currently, it's easier to refactor within a program than across services.
Definitely.
Yep.
And it's easier to get started, too, because you don't have 15 different things you have to spin up and check 15 different logs on.
Yeah. No, I definitely am very interested. We're slowly starting to transition to services by breaking off little things around the edge of the monolith, break those out into services. So we're evolving that way. So it'll be really, really interesting experience to see how that goes. You may have to invite me back in a year or two when we're further along, and I can tell you about that.
Definitely. And I think that the service approach might have another side effect, Brad, that harkens back to something you talked about earlier, and that is treating active record as a persistence layer and keeping the business logic out of it. If you have a persistent service that's free of business logic, I think it follows that pattern pretty well.
Yeah, and what's interesting is if you look at, I just barely have started to scratch the surface, I've just only looked at it a little bit, the Phoenix framework, which is, of course, the web framework for Elixir. You can already see that they're taking that lesson to heart. So the Phoenix ORM, which is called Ecto, is interesting because first of all, it uses the repository pattern instead of the active record pattern. So, you say basically my repository dot users dot, and then you kind of string together basically kind of SQL commands dot where or dot limit or whatever. What it returns is just structs, the simplest data structure possible with no methods. So that, that's a pretty radical departure. Other parts of Phoenix are very, very, very heavily inspired by Rails, you can tell, but they definitely did a 180 in their persistence layer. What's kind of funny is that when I started talking about models that do very, very little, people accuse me of you're following what Martin Fowler calls the anemic model pattern, and he calls it the anemic model anti-pattern. Turns out, the sort of next generation of ORMs is sort of not only turning anemic models, they're not really models at all. They're just structs of data. It's just data. In other words, that separation and using an ORM as a thin wrapper is enforced from the very get-go.
That's awesome. I love Elixir. I love Phoenix. And Ecto is pretty interesting.
I would push back a little on the idea that the repository pattern supports anemic models. I mean, at least as documented in Fowler's book, repositories are often there to feed your mappers, which are a way to map data into rich domain objects. So I'm kind of confused about how that supports an anemic domain.
Can somebody define the repository pattern?
Yes, please.
So the repository pattern is in sort of contrast to it's a little bit in contrast to the active record pattern. From what I understand, those are the two types of object relational mappers. The two primary types are active record style and repository style. In active record style, you kind of have these classes that say, okay, so here's a class called user, which corresponds to my user table. When I run a query, basically, I'm using the database to hydrate this user object with data, which then has methods, hanging off that allow me to operate on that class. Whereas the repository pattern says, here's a repository that represents my whole database, and I'm going to basically run SQL queries off that, start chaining methods together that generate SQL query that returns an object. So in my opinion, just aesthetically speaking, repositories seem to me Some people might disagree with me on that, but they seem to be a little more SQL focused, a little more explicit as a querying mechanism, whereas active record models, seem to try to hide the implementation details a little bit more and try to allow you to do object-oriented programming with less knowledge of actually how the database works or how the querying has happened.
I'm going to be.
Yeah, go ahead.
I'm going to be pedantic for a moment. So I want to make it clear that I'm not arguing with your like choice of how to structure applications. I think that's kind of a separate question. But just in terms of keeping terms clear, what you just described is sort of the exact opposite of the repository pattern.
Okay.
The repository pattern is actually a higher level, less SQL focused pattern than the active record pattern. And again, when I say actually, obviously there is no God did not set these patterns down in stone. But if we're going to go by the terms that Fowler's talking about, repository is much more abstracted from the SQL layer. And it basically ties in a bunch of the lower level patterns in order to interact with the database without really thinking about the database. It actually gets a little closer to like the object-oriented database view of the world. It's an intermediary layer between your data store and your domain objects that uses things like query objects, so you don't have to have like raw SQL. And the one of the things that confuses all this and makes it more difficult is that as Active Record has sort of grown and metastasized, it has grown to it's this blob that has slowly eaten up like the entire Patterns of Enterprise Application Architecture book. It started out as an implementation of one of the patterns in there, and now it's like all of the patterns in there. And Active Record actually includes a good chunk of some parts of Data Mapper and basically all of repository at this point.
Interesting.
Active Record is the worst branding ever.
Because it includes the concept of taking a query object, in other words, something that abstractly represents a query without actually writing SQL, and applying that to a repository and, getting a result set and using the result set to populate domain objects, and all that stuff gets rolled into Active Record. Of course, that means it isn't really Active Record anymore. So it's very confusing. So yeah, terminology gets confusing when people start naming their libraries after patterns and then evolving the libraries.
Naming is dangerous.
I think what's interesting that you mentioned is my understanding of repository versus active record may very well be totally wrong, because I tend to use object relational mappers in ways that they weren't necessarily designed for. I'm sort of an ORM rebel here. But we mentioned hiding SQL and allowing you to do OOP in a way that hides those implementation details, that encapsulates your queries. My big question or my contention with that is, why do we want to do that? In particular, SQL is a fantastic language. It is one of the great success stories of computer programming. It was created in the early 70s. It's immensely powerful. During the whole NoSQL binge that everyone went on, from 2005 to 2012, when everyone was saying, we finally passed SQL, we're finally onto something better with all these NoSQL databases. Everyone was crying the death knell for SQL. Now, the newest, greatest databases look at like Google F1 and some of the open source sort of derivatives of people who are trying to do the same thing have all gone back to SQL. In other words, it's the only thing we all still use every day. Well, I guess besides Unix, but it's the only thing we all still use every day, or at least the old programming language that we all still use, because there's still nothing better. I always thought it was a mistake to try to hide the SQL from the web app. In fact, I look at web apps as basically the code between the browser and the SQL query engine, and I've particularly found that it becomes problematic hiding SQL when you're onboarding junior developers, when you're teaching junior developers. There seems to be a trend to try to allow people to write a web app with a SQL database without knowing SQL. And quite honestly, I think it's a big mistake. Not only because does it result in poor SQL, N+1 queries and things like that, solutions that aren't scalable, which is a problem, at a fast-growing company. But also SQL is just great in itself, and I don't know why you'd want to hide it.
One of the arguments I've heard against using raw SQL is database portability, and that's something we've talked about on the show before. But if you're going down to raw SQL, it's hard not to use database-specific functionality in your queries, because SQL is not – there may be a SQL standard, but the implementation is not standardized.
Yeah, I've heard that one often. And just to be clear, I don't necessarily mean writing just raw SQL. You could just be easily using something like Active Record in a way that's very SQL forward. Like, for instance, in a service object, doing user.joins, .where, .limit, in a way that makes your calls to Active Record look like a single SQL query. In other words, SQL-aware use of Active Record. But then there's the other argument, the portability one I have heard, but I don't know about you, I've never been on a project, where in a commercial project where we're, in a business that we're trying to support, where it's like we get in there and it's like, oh my God, we've got to switch to Mongo, or Postgres just isn't doing it. We've got to switch to MySQL.
I think some people are facing that now with Amazon's database service, which is based on MySQL instead of Postgres.
Yeah, I think that's definitely valid. Like if these things are hard, because we encode variability based on, what we thought was going to vary at one time. And then down the road, it turns out that's really not the thing that we vary at all. I think a lot of the sort of, the need to have abstract SQL, to abstract away from proprietary SQL, maybe not as many projects need that anymore. But like Coraline just said, some may discover that, oh, hey, we need to move to Amazon's SQL store, and suddenly it is an issue.
Of course, that's going to be painful no matter what.
But I mean, there are different, and and there's a limit to how far you can abstract. I mean, it's just, you're not going to suddenly switch, from a SQL store to Mongo and have your magical data mapper just support that, because often you're talking about moving not just from just swapping out your data store, but you're swapping out a lot of the semantics of how you think about your data, and that's got to be reflected. But I mean, there are definitely intermediate layers, between the really high level object mappers and the low level SQL access. I mean, one of the things that I love using these days is the SQL Ruby gem, which, the spelled out SQL Ruby gem, which is wonderful because it lets you execute queries against your tables using an abstracted interface, but only very lightly abstracted. I mean, you're not necessarily writing raw SQL, but you're writing something very close to it. And it'll work just fine against your SQLite or against your Postgres or against your MySQL. But that what you're writing is against some kind of SQL. And then it's just returning, arrays of hashes back. And I think, Brad, it sounds like that's a lot like what you're talking about. And the patterns that I relate that to go back to the POEAA book, are like the row data gateway and the table data gateway patterns, along with the data transfer objects, which, are really dumb objects for moving data around.
Basically structs.
Yeah,
exactly.
You had a good point there, Brad, about exposing SQL, whether it's slightly abstracted or literal SQL, being useful for onboarding new people. I've experienced that at new jobs. There's all this code, and I don't know what, especially in a dynamic language, I don't know what is in this, if it's Clojure, map of maps. And then I get to something with SQL in it, and I'm like, I know what this does. I can go look at it in the database and see exactly what's coming back. I think that's really good for code readability.
Yeah, I try to architect applications in a way to prevent sort of a malady that I call database denial. Database denial is this thing that affects a lot of web applications, which it's when you use high-level abstractions over SQL that hide querying and brings you problems like N+1 queries, lack of explicit opening and closing of database transactions, and various other things. Querying in multiple layers, for instance. I've seen a lot of people who are new to Rails, for instance, start to sort of naively write Active Record and end up with queries in the model, in the controller, in the helpers, and in the views. So I try to pick architectures that acknowledge the presence of SQL there, that work with SQL, make it sort of, even if it's through an ORM as a thin layer, that make SQL queries a first-class citizen to avoid all those symptoms of database denial.
I think one of the things that we have been taught by the whole NoSQL movement, and what started that, was recognizing not all data is the same. Not all of it needs to be stored the same. Not all of it needs to be updated the same and has the same constraints. And then we got all these different alternative databases, and now we're like, but the SQL databases are so good, which is true. But also I think we can keep that realization that the database doesn't just magically work. We have to think about what we're putting into it and what the requirements are under different circumstances. And then, like you said, explicitly start and end transactions so that people can see what's happening.
Problem I have with not being with databases, I guess, and especially Active Record lends itself to this, is persistence first thinking. Not every domain object needs to be persisted, like you said, Jessica, in the same way. But I think that when you're starting an object with a migration, you're thinking data first. You're thinking state first. And I think that can sometimes be a problem.
Yeah. When I was first programming, that is totally how I learned to do it. First, you design the database model, the relational model for the things, and then you layer on the program from there. And yeah, you're right. We can kind of move past that and think about the flow of data and actions. Because there is more than one way to store the things. The relational model is not our only model anymore. Avdi, I'm so glad that you're on it with these patterns and defining them. And
just to be extremely clear, I think that the questions that Brad, that you're bringing up are really important ones. I think they're ones a lot of people are asking, and I think these are things that are very important to reconsider. So I'm not arguing at all about, do we need, I think it's good to ask, do we need this sort of high level denial of the database? Yeah, I only bring up the definitions of patterns from the books just for clarity's sake. That's all.
It's helpful.
But just because the pattern exists doesn't mean it's necessarily something you need to use.
Is there a name? Is there a name for the just barely abstracted SQL style?
Well, like I was saying, the patterns that are interesting to look at for that if you're going to go to the POEA book, which I always recommend going to just because there's so much wisdom in there, are the table data gateway, the row data gateway, and then like the data transfer objects, which, represent a very lightweight way of moving data around without building a big model around it. Those
are very familiar from my Java days.
Yeah.
Yeah. It's curious to hear you say that, Avdi. I watched recently your talk. It was your keynote from, I forget which Ruby conference, the one in Texas about formalism. And it's
yes.
funny to hear the gentleman who is decrying the end of formalism talk about, in the most formal way possible, the definitions of data structure of design patterns.
A foolish consistency is a hobgoblin of little minds.
This is the perpetual contradiction that I have to live in every day. And I try to, I guess my personal mission right now is sort of the constant recognition that formalisms are things that people invent, that they are always contextual, that terms for things, well-defined terms for things can be tremendously useful. And especially if everybody is familiar with the source material and actually understands what the term they're using means. But bottom line, they're always invented. They're always contextual. They always embed unstated assumptions about what is important and what isn't important, and what things are things and what things are not things. Because the things that have no names in your pattern language are things that you're implicitly denying, and that can be a problem too.
Sapir-Whorf effect.
Yeah. So know your context, but do not be limited by your context.
It's the Sapir-Whorf effect.
Sapir-Whorf hypothesis states that language influences and constrains our thinking about things. So if you have no word in your language for different shades of blue, you don't perceive those shades of blue, basically.
Right. And Avdi mentioned something there that also relates to what Brad said about onboarding. These names are great if everyone knows them, but if you're using them in a context where people don't know them, then they can actually add confusion. For instance, monad.
It's burrito,
right? Exactly.
It's a spacesuit.
But you can establish those, and if you consciously recognize that, then you can say, okay, when you work here, if you don't know SQL yet, please learn SQL. When that's expressed and it's explicit, then you're not adding confusion. People know what context they need to gain for it to make sense.
All right, well, I'm going to push us into picks. Before we get to the picks, I just want to acknowledge our silver sponsors. Once again, this episode is sponsored by Braintree. Go check them out at braintreepayments.com/rubyrogues. If you need any kind of credit card processing or payment processing in general, they are a great way to go, and we appreciate them sponsoring the show. There are a lot of exciting things happening in JavaScript. 1 or 2 conferences a year just aren't enough to keep up. Then there's the travel and hotel and food and getting to and from the airport, which is both time-consuming and a hassle, and expensive. This is why I've put together JS Remote Conf. It's a 3-day online conference where you'll get 12 talks about the latest stuff going on in JavaScript. We already have talks lined up with people you know, like Aaron Frost, Amy Knight, AJ O'Neill, and John Papa. You can get your tickets and more information at jsremoteconf.com. Coraline, do you want to start us off with picks?
Sure. Lately, I've been getting into history, and I don't know about you, but I didn't have very much history in high school and college, at least college before I dropped out. So I feel like I have a lot to learn in this domain. And so I went looking for a couple of history podcasts, and I found a couple that I really like. The first is Hardcore History. It's a podcast by Dan Carlin. It's considered by many to be the history podcast. Carlin does really, really well-researched episodes, and the production value is extremely high. It feels more like an audiobook than a podcast. So that means he doesn't come out with new episodes very frequently, but when he does, they're super high quality. So Hardcore History. The other one I enjoy, which is a little lighter and a little bit more entertaining, is put out by the people behind How Stuff Works. It's called Stuff You Missed in History Class. It's full of really interesting trivia. I just listened to the episode on Sir Isaac Newton, and I learned a lot about Isaac Newton. And they have episodes ranging from the Oregon Trail all the way to the history of peanut butter. So they don't take themselves too seriously, but there's always something to learn on that podcast.
All right. Jessica, what are your picks?
I too much pressure. I don't have any picks today.
Okay. Avdi, what are your picks?
So I think I'll pick a social media tool I've been using lately called Buffer. And some folks might have heard of Buffer. It's sort of marketed as a way to maintain your social media engagement by always having tweets and stuff coming out all the time and whatever. I like Buffer not because it lets me be constantly filling my buffer with stuff, but because it's write only. That's why I like it. If I install it on my phone, it doesn't give me a way to read Twitter. It just gives me a way to write to Twitter. And not only that, the stuff that I stick in there isn't going to post for a while, which means that I can't start obsessively checking Twitter for replies to whatever I wrote because it's not even up yet. And by the time it does go up, I don't care nearly as much about it as I did when I first posted it. And so I'm not going to check for replies then. And basically it means I get more done and I don't think about social media quite so much. So I like Buffer for managing my own brain, not for managing my social media engagement. Other than that, I'm going to do a beer pick. It is the season of winter beers, and I recently tried the New Belgium Accumulation White IPA, and it's a really exceptional beer. I really, really liked it. So if you can find it, check that out. And that's it for me.
Awesome. I've got a quick pick here. I haven't had a chance to try it yet, but I did get it set up the other day. It's a Ceramonic Smart Mixer. What it is it goes on your tripod, kind of like for a camera, except it has a clip for your smartphone, and then it has an audio input-output that has a couple of microphones on it that you can kind of point at yourself while you're shooting video with your phone. And it hooks directly into the phone. It also has an XLR plug if you want to hook it into something like a mixer. Obviously, you can also plug it into a computer. And the reason I'm doing that is because I want to get back into doing Periscope videos every morning. And so I got that. I got it all hooked up and set up. I actually did a Periscope on unboxing it. But yeah, it's kind of hard to explain exactly how it's shaped, but basically right above the phone, it has this little box that has the microphones on it that you point at yourself. And that way I can get things set up in here so that I can just talk to my phone or talk to my computer and have it pick up and record and do all the right stuff. So I'm kind of excited to play with it. I'll put a link to it in the show notes, and then you can go see how goofy looking this thing is. But I think it's going to work out, and I think it's going to be fun, and I'm planning on recording quite a few videos with it. So that's my pick. Brad, what are your picks?
So first of all, a really neat program out of St. Louis called LaunchCode. LaunchCode is a nonprofit that places beginning programmers in their first jobs in pair programming positions. So not a boot camp, more of an apprenticeship program called the kind of model. It's a program that has placed almost over 200 people in new programming jobs and is spread out of St. Louis into 3 or 4 other cities, and has made some visits to the White House. If you're interested in the future of tech hiring, definitely check out LaunchCode. They're doing really, really, really neat things. The second is a book called Turing's Cathedral, The Origins of the Digital Universe. This is a history book, Coraline. You probably like it. It's by George Dyson, and it is the story of the invention of the first computer at the Institute of Advanced Studies at Princeton in the late 40s and early 50s. It features such interesting people as Robert Oppenheimer, Alan Turing, Kurt Gödel, and the star of the show, John von Neumann, who a lot of people credit with basically inventing the modern computer. It's a neat story mixes the invention of the atomic bomb with the invention of the first computer. Finally, since we're nearly into holiday season here, I want to call it VAT19.com, VAT19, VAT19.com. It is an e-commerce site that sells a lot of really, really, really unique and cool gifts, things you can't find on Amazon. It's a small business run by a friend of mine in St. Louis, and every product they sell comes with a YouTube video. They've garnered hundreds of millions of page views. People love them. It's a great, neat, feel-good shop if you can't find, what you're looking for on, the typical Amazons and Walmarts of the world. Check that out for something unique and different.
All right. Well, I think that's it. So we'll go ahead and wrap this up. Brad, if people want to follow up with what you're doing or check out what you're about, where do they go?
You can follow me on Twitter at Brad Urani. It's my name, BradUrani. I have a blog at fractalbanana.com. Those are the two best places to find me.
What does a fractal banana look like?
Well, it's like a banana, but when you zoom in and you look closer at it, you just see more bananas.
It's bananas all the way down.
Bananas all the way
gotcha.
down. Yeah.
All right. Well, we'll go ahead and wrap this show up, and we'll catch y'all next week. Hosting and bandwidth provided by the Blue Box Group. Check them out at bluebox.net. Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more. Would you like to join a conversation with the Rogues and their guests? Want to support the show? We have a forum that allows you to join the conversation and support the show at the same time. You can sign up at rubyrogues.com/parlay.